is my great honor to serve as the designated federal officer for today's 164th Vaccines and Related Biological Products Advisory Committee meeting. On behalf of the FDA, the Center for Biologics Evaluation and Research, and the committee, I would like to welcome everyone to today's virtual meeting. The topic of the meeting, as Dr. Manto mentioned, is emergency use authorization of Janssen Biotech's COVID-19 vaccine for active immunization to prevent COVID-19 caused by SARS-CoV-2 in individuals 18 years and older. Today's meeting and the topic were announced in the Federal Register notice that was published on February 11, 2021. I would like to introduce and acknowledge the excellent contributions of the staff in my division and the great support team we have in preparing for this meeting. Ms. Kathleen Hayes is my backup and co-DFO, providing excellent support in all aspects of preparing for and conducting this meeting. Seabird's sincere appreciation to Mike Kaczynski in facilitating the meeting for today, and also a big shout out to many FDA staff working hard behind the scenes, trying to ensure that today's virtual meeting will also be a successful one like the previous three were packed meetings on the COVID topics. Please direct any press or media questions for today's meeting to FDA's Office of the Media Affairs at FDA-OMA, one word, at fdahhs.gov. The transcriptionist for today's meeting is Ms. Linda Giles. We will begin today's meeting by taking a formal roll call for the committee members and temporary members. When it is your turn, please turn on your camera, unmute your phone, and then state your first and last name. And when finished, you can turn your camera off so we can proceed to the next person. Please see the member roster slide in which we will begin with the chair. Dr. Arnold Manto, can we start with you, please?
Good morning again, and welcome to all.
I think, Dr. Manto, your volume is a little bit low. If you can improve it, that would be great. Thank you. Dr. Amanda Cohn.
Good morning, Dr. Amanda Cohn, Chief Medical Officer, National Center for Immunization and Respiratory Diseases.
Thank you. Dr. Chatterjee?
Good morning. My name is Archana Chatterjee. I am the Dean of Chicago Medical School and Vice President for Medical Affairs at Rosalind Franklin University of Medicine and Science. I'm a pediatric infectious diseases specialist with a background in research in vaccines. Thank you.
Yes. Dr. Cody Meissner.
Good morning. My name is Cody Meissner. I'm a professor of pediatrics at Tufts University School of Medicine and head of the infectious disease service at Tufts Children's Hospital in Boston. Thank you.
Great. Next slide, please. Dr. Gans.
Good morning. I'm Dr. Haley Gans. I'm the professor of pediatrics and pediatric infectious disease at Stanford University, and I currently do research on the immune response of different infectious disease pathogens in children and special hosts, including vaccines. Thank you.
Next to Dr. Kurila.
Mike Kurila. I'm a pathologist by training, currently director of the Division of Clinical Innovation at the National Center for Advancing Translational Sciences within the National Institutes of Health.
Dr. Offit.
Yeah, good morning. I'm Paul Offit, a professor of pediatrics at the Children's Hospital of Philadelphia and the University of Pennsylvania School of Medicine.
Okay. Dr. Annunziato. Hala. We can't hear you. You need to unmute your phone.
Good morning. My name is Paula Annunziato. I'm Vice President and Therapeutic Area Head of Vaccine Clinical Development at Merck, and I'm the non-voting industry representative this morning.
Thank you. Dr. Pagum.
Hi, I'm Steve Pergam. I'm an associate professor at the Fred Hutchinson Cancer Research Center and the University of Washington.
Great. Next slide, please. Dr. Fuller.
Good morning. I'm Evita Fuller. I'm associate professor in microbiology at the University of Michigan and a member of the STEM initiative in the African Studies Center, and I'm a virologist by training.
Dr. Kim. You are muted. Dr. Kim, you need to unmute your phone.
Sound check, is this working better?
Yes, can you start again? Thank you.
This is David Kim, Director of the Division of Vaccines and the Office of Infectious Disease at the HIV/AIDS Policy and HHS Office of Assistant Secretary for Health.
Thank you. Dr. Rubin. You have to unmute yourself, Dr. Rubin.
Wrong button. Hi, I'm Eric Rubin. I'm at the Harvard T.H. Chan School of Public Health, the Brigham and Women's Hospital, and the New England Journal of Medicine.
Thank you. Dr. Hildreth. Dr. Hildreth.
I'm here. Good morning. I'm James Hildreth. I'm president of Meharry Medical College and professor of internal medicine. I'm a viral immunologist, and I study the way that the body responds and clears viruses from our system. Thank you.
Thank you. Dr. Portnoy.
Good morning. I'm Dr. Jay Portnoy. I'm a professor of pediatrics at the University of Missouri, Kansas City School of Medicine in the Division of Allergy Immunology at Children's Mercy Hospital in Kansas City, Missouri. And today I'm serving as the consumer representative.
Thank you. Dr. Lee.
Good morning. My name is Jeanette Lee. I'm a professor of biostatistics at the University of Arkansas for Medical Sciences. Thank you.
Thank you. Dr. Mark Sawyer. You have to unmute yourself, Dr. Sawyer. Still can't hear you.
There we go. We
now.
you, Dr. Sawyer.
Try again, sorry. Mark Sawyer, professor of pediatric infectious disease at the University of California, San Diego, and Rady Children's Hospital, San Diego.
Thank you, Dr. Sawyer. Dr. Watson.
Good morning. I'm Melinda Horton. I'm Director of the Immunization Services Division at the Centers for Disease Control and Prevention, and I'm an adult infectious disease physician by training.
Thank you. Dr. Ofer Levy.
Good morning. My name is Ofer Levy, and I'm Director of the Precision Vaccines Program and an attending physician in the Division of Infectious Diseases at Boston Children's Hospital and a professor of pediatrics at Harvard Medical School.
Thank you. Next slide, please. Dr. McInnes.
Good morning. My name is Pamela McInnes, recently retired Deputy Director of the National Center for Advancing Translational Sciences, a component of the National Institutes of Health. Thank you.
Thank you, Pam. Dr. Moore.
Good morning. I'm Patrick Moore. I'm at the University of Pittsburgh Cancer Virology Program, and I study cancer viruses, two viruses that we've covered here.
Thank you. Dr. Perlman.
Good morning. I'm Dr. Stanley Perlman.
the University of Iowa, Department of Microbiology and Immunology. I'm a long-term coronavirus researcher, and I'm also a pediatric infectious disease.
Thank you, Dr. Perlman. Dr. Marasco. Wayne?
I don't think Dr. Marasco has his audio connected at the moment.
Okay, so we will move on then. In the interest of time, when he comes, maybe later we can introduce him. So next, thank you all. Next, I would like to introduce the FDA staff, Dr. Marian Gruber, Director of the Office of the Vaccines, who will say a few welcome remarks. Dr. Gruber, please turn your camera and unmute your phone, please. We can't hear you, Marian. You have to unmute yourself.
Yeah, I know. Okay, sorry. Yeah, good morning to everybody. My name is Marion Gruber. I'm the Director of the Office of Vaccines Research and Review at the Center for Biologics, FDA. And on behalf of my colleagues in the Office of Vaccines, I would like to welcome this morning the committee, Janssen, as well as the public to this discussion. And again, once again, I really would like to express my appreciation for the committee to take time out of their busy schedule to come together and lend their perspective, advice, and recommendation regarding the topic at hand today. And we'd like to really hear from them, whether the totality of the evidence and the data that are presented today by Janssen and the FDA will support authorization of their COVID vaccines under an EUA. So I look forward to today's discussions. Thank you.
Thank you, Dr. Gruber. I would also like to acknowledge the presence of Dr. Celia Witten, Deputy Director of CBER, and Dr. Philip Krause, Deputy Director of the Office of Vaccines at this meeting, who may chime in later as needed. Dr. Peter Moss, our Center Director, will join us after I complete the reading of the conflicts of interest statement to make his remarks. Now I will proceed with the reading the conflict of interest statement. For the record. Okay, FDA conflicts of interest disclosure statement read for the public record by Dr. Prabhakara Acharya, Director of the Division of Scientific Advisors and Consultants, and the designated federal officer for today's meeting. The Food and Drug Administration, FDA, is convening virtually today, February 26, 2021, the 164th meeting of the Vaccines and Related Biological Products Advisory Committee, VRPAC, under the authority of the Federal Advisory Committee Act, FACA of 1972. Dr. Arnold Manto is serving as the acting voting chair for today's meeting. Today, the committee will meet in open session to discuss the emergency use authorization of Janssen Biotech Incorporation's COVID-19 vaccine for the active immunization to prevent COVID-19 caused by SARS-CoV-2 in individuals 18 years or older and older. The topic is determined to be a particular matter involving specific parties. With the exception of industry representative members, all standing and temporary voting members of the committee are appointed special government employees or regular government employees from other agencies and are subjected to federal conflicts of interest laws and regulations. The following information on the status of this committee's compliance with federal ethics and conflicts of interest laws, including but not limited to 18 United States Code Section 208, is being provided to participants in today's meeting and to the public. Related to the discussions at this meeting, all members, regular government employees and special government employee consultants of this committee have been screened for potential financial conflicts of interest of their own as well as those imputed to them, including those of their spouse or minor children, and for the purpose of 18 U.S. Code 208, their employers. These interests may include investments, consulting, expert witness, testimony, contracts, grants, cooperative research and development agreements or CRADAs, teaching, speaking, writing, patents, royalties, and primary employment. These may include interests that are current or under negotiation. FDA has determined that all members of this advisory committee, both regular members and temporary members, are in compliance with the federal ethics and conflicts of interest laws. Under 18 U.S. Code 208, Congress has authorized FDA to grant waivers to special government employees who have financial conflicts of interest when it is determined that the agency's need for a special government employee's expert services outweighs the potential for a conflict of interest created by the financial interest involved, or in the case of regular government employees from other agencies, when the interest of regular government employee is not so substantial as to be deemed likely to affect the integrity of the services, which the government may expect from the employee. Based on today's agenda and all financial interests reported by the committee members and consultants, there have been one conflict of interest waiver issued under the U.S. Code 208 in connection with this meeting. As you have seen before, we have the following consultants serving as temporary voting members: Dr. Ovita Fuller, Dr. James Hildreth, Captain David Kim, Dr. Janet Lee, Dr. Ofer Levy, Dr. Wayne Marasco, Dr. Pamela McInnes, Dr. Patrick Moore, Dr. Stanley Perlman, Dr. Eric Rubin, Dr. Mark Sawyer, and Dr. Melinda Watson. Among all these consultants, Dr. James Hildreth, a special government employee, has been issued a waiver for his participation in today's meeting. The waiver was posted on FDA website for public disclosure. Dr. Paulo Annunziato of Merck will serve as the industry representative for today's meeting. Industry representatives are not appointed as special government employees and serve as non-voting members of the committee. They also act on behalf of all the regulated industry and bring general industry perspective to the committee. Industry representative on this committee is not screened, does not participate in a closed sessions if held, and does not have voting privileges. Dr. Jay Portnoy is serving as the acting consumer representative for this committee. Consumer representatives are appointed special government employees and are screened and cleared prior to their participation in the meeting. They are voting members of the committee. Disclosure of conflicts of interest for speakers and guest speakers follows applicable federal laws, regulations, and FDA guidance. FDA encourages all meeting participants, including open public hearing speakers, to advise a committee of any financial relationships that they may have with any affected firm, its products, and if known, its direct competitors. We would like to remind the standing and temporary voting members that if the discussions involve any other products or firms not already on the agenda for which an FDA participant has a personal or imputed financial interest, the participants need to inform the DFO and exclude themselves from such involvement, and their exclusion will be noted for the record. This concludes my reading of the conflict of interest statement for the public record. At this time, I would like to welcome our Center Director, Dr. Peter Marks, to address the committee. Dr. Marks? Go ahead, please.
Good morning. I'm Peter Marks, Director for the Center for Biologics Evaluation and Research. On behalf of the FDA, I want to welcome everyone to this 164th meeting of the Vaccines and Related Biologics Products Advisory Committee meeting. Thanks to the committee members, the sponsor, the FDA staff, and other presenters, and to all other interested parties for participating in this meeting today. We look forward to a very productive day as we consider the third emergency use authorization submission for a COVID-19 vaccine, this one from Janssen. We greatly appreciate everyone's participation, and we also appreciate your patience. We know that the AV can have issues, and after our 7th or 8th or 9th emergency use authorization for a vaccine, we'll probably get it perfect. But for today, thanks for bearing with us, and we really look forward to a very productive day. I'll turn this back over to Prabha in the chair.
Okay, Dr. Marks, thank you so much. Now I will hand over the meeting to our chair, Dr. Arnold Manto, Dr. Monto, the meeting is yours. Please take it away. Thank you.
Thank you very much. Thank you very much, Prabha. I'd like to invite first Maria Allende, Branch Chief, Clinical Review Branch of the Office of and Vaccine and Research and Review of CBER, to present a view of the FDA's emergency use authorization. Dr. Allende, the floor is yours.
Dr. Allende, let's make sure you unmute yourself.
Okay.
There you go. Perfect.
Okay. Good morning, everybody. My name is Dr. Maria Allende. I'm Chief of the Clinical Review Branch 1 of the Division of Vaccines and Related Product Applications in the Office of Vaccines Research and Review at the Center for Biologics Evaluation and Research of the FDA. I will provide an overview of the regulatory basis for emergency use authorization and considerations for COVID-19 vaccines. As a way of introduction, this slide summarizes the current status of the COVID-19 pandemic according to the latest data published online by the CDC. More than 28 million cases have been reported, and deaths have surpassed 500,000 in the U.S. as of this week. Even though there is a decreasing trend in the last 5 weeks, there are more than 400,000 new cases and more than 2,000 deaths reported during this past week, ending on February 24th. On December 11th, 2020, FDA issued an emergency use authorization for the Pfizer-BioNTech COVID-19 vaccine for prevention of COVID-19 disease due to SARS-CoV-2 in individuals 16 years of age and older. A week later, on December 18, 2020, an EUA was issued for the Moderna COVID-19 vaccine for prevention of COVID-19 disease in individuals 18 years of age and older.
Dr. Allende, hold on one second. Just hold on one second. And this is to the public too. We do have, since Janssen is overseas, we do have overseas callers dialing in all the time. So give us 1 second while we pause. Whoever is our 2302 number, please stop interrupting. Sorry about that. So Dr. Allende, take it away.
Okay. Should I press anything?
No, you're good. Go ahead.
Okay. So I will restart. On December 11, 2020, FDA issued an emergency use authorization for the Pfizer-BioNTech COVID-19 vaccine for prevention of COVID-19 disease due to SARS-CoV-2 in individuals 16 years of age and older. A week later, on December 18, 2020, an EUA was issued for the Moderna COVID-19 vaccine for prevention of COVID-19 disease in individuals 18 years of age and older. Both of these COVID-19 vaccines remain unapproved products and are not available in sufficient quantities to address current public health needs. Thus, there is no adequate, approved, and available alternative in the U.S. for prevention of COVID-19. Janssen's EUA request was submitted on February 4, 2021 for its adenovirus vector vaccine known as Ad26-COVID2S, administered as a one-dose regimen. The proposed indication is for active immunization to prevent COVID-19 caused by SARS-CoV-2 in individuals 18 years of age and older. The information submitted in support for this request includes safety and efficacy data from more than 43,000 randomized participants in their multinational blinded placebo-controlled phase 3 trial COV3001, known also as Ensemble. Participants were enrolled from 8 countries: the United States, Argentina, Brazil, Chile, Colombia, Mexico, Peru, and South Africa. And we will be hearing details about this trial, and the data from it is going to be discussed during this afternoon session. FDA has been conducting a comprehensive review of the Janssen COVID-19 vaccine EUA submission received on February 4th, 2021, and this is in addition to several months of completed review work done on materials and information submitted previously in support and preparation for the EUA request. Our review of the EUA includes verification of clinical data integrity and Janssen's analysis and additional FDA analysis from data sets provided in the submission. Ongoing review of manufacturing, non-clinical, and clinical assay information, review and revision of prescribing information and fact sheets to inform and instruct vaccine recipients and healthcare providers, along with Janssen in this task. Multiple information requests have been sent to Janssen, and we have been exchanging daily communications to address questions and clarifications on the data submitted. And last but not least, also, we have been preparing for today's VRBPAC meeting. Today's VRBPAC meeting, in which the committee will advise the FDA with its own independent assessment of the data, continues FDA's commitment to an expedited review process that is transparent, scientifically sound, and data-driven. And this slide is presented for your reference, describing the legal basis for issuing an EUA and was presented in the two previous advisory committee meetings last December. As a reminder, the Health and Human Services Secretary issued a declaration on March 27, 2020, justifying the EUA of drugs and biological products to address the COVID-19 pandemic. An EUA for diagnostic assays had been issued prior to that in January 2020. The criteria for FDA issuance of an EUA for diagnostic, prevention, or treatment purposes require the existence of a serious or life-threatening disease or condition for which the product's known and potential benefits outweigh its known and potential risks. No adequate approved alternative to the product are available for diagnosing, preventing, or treating the disease or condition for which is being issued. The Pfizer, BioNTech, and Moderna COVID-19 vaccines are available under EUA for prevention of COVID-19, but remain unapproved products, and quantity available for mass vaccination is currently limited. The FDA expectations for COVID-19 vaccine EUAs were discussed previously at the October 22nd and December 10th and 17th, 2020 advisory committee meetings, and are described in the FDA guidance Emergency Use Authorization for Vaccines to Prevent COVID-19, published in October 2020 and recently updated on February 22nd, 2021. There are three areas under which our expectations are covered. Data, the first, data to demonstrate manufacturing quality and consistency, clear and compelling safety and efficacy data to support favorable benefit risk of the vaccine when rapidly deployed for administration to millions of individuals, including healthy people, and plans for further evaluation of vaccine safety and effectiveness, including in ongoing clinical trials, active and passive safety monitoring during use under EUA, and observational studies.
The issuance of an EUA for COVID-19 vaccine will specify conditions of use for which benefit risk has been determined to be favorable based on review of available data. Will provide information to vaccine recipients and healthcare providers by way of prescribing information and fact sheets that will necessarily include our review of the data. An EUA may be revised or revoked if other circumstances arise that warrant changes necessary to protect public health or safety, for example, based on new available information. And this is an overview of today's agenda. Yes. Next, we will hear two presentations from our CDC colleagues, Drs. Adam McNeil and Tom Shimabukuro, and Dr. Stephen Anderson from FDA, who will present the epidemiology of COVID-19 variants and post-marketing surveillance from currently authorized COVID-19 vaccines. After a 10-minute break, we'll listen to the sponsor presentation, Janssen, and we'll break for 30 minutes for lunch after that. And after lunch, we'll have the open public hearing, which will be followed by the FDA clinical review presentation by our colleagues, medical officers from FDA, Drs. Rachel Zhang and Josefa Hefter, and voting questions. And the last but not least item in the agenda will be the committee discussion and voting, after which we'll adjourn the meeting. So as a preview and to keep in mind during today's presentations and discussions, here is the question for the committee. Based on the totality of scientific evidence available, do the benefits of Janssen COVID-19 vaccine outweigh its risk for use in individuals 18 years of age and older? Thank you for your attention. This concludes my presentation.
Thank you, Dr. Allende. Before I open the meeting up to the members for questions, let me ask you about the basis for emergency use relative to the guidelines that appeared this autumn. Are we still working on the basis of 50% or more vaccine effectiveness, which was the guideline at that point, and 2 months of follow-up for safety? Are those still our considerations?
Yes, Dr. Monto, those are still remain our standards. At least a point estimate of 50% of risk reduction compared to placebo, and a lower bound of at least 30% are still the standards that we expect.
So the standards are exactly the same as in the previous reviews on the 10th of December and the 17th?
Yes,
okay.
The standards have not changed. Mm-hmm.
Please raise your virtual hands, those that have questions. Dr. Kurilla.
Thank you. Thank you, Arnold. Maria, just curious regarding what are the expectations after the issuance of an EUA in terms of follow-up? Are there routines, periodic updates, or what? How are you monitoring the status of the EUA with regard to your relationship with the company, the sponsor?
Thank you, Mike, for your question. Yes, we expect continuous active and passive safety reporting and surveillance, and also observational studies and more prolonged follow-up of the ongoing study. So it's a mixture of continuing follow-up in the current study and reporting by ways of several networks that we have in collaboration with CDC, and also observational studies. So the data, we expect to receive additional data from several of these sources to further evaluate.
Okay, Dr. Meisner.
I
You're
can't
muted.
hear.
Thank you. Thank you, Arnold, and thank you for that clear presentation. And I would like to follow up on Dr. Monto's question. Because the strains of SARS-CoV-2 that are circulating now may be somewhat different than the strains that were circulating during the trials with the messenger RNA. And so the efficacy at preventing relatively mild or even moderate disease may be different. But yet, all of the vaccines seem to be equally effective at preventing very severe disease, intensive care need, and deaths. And it's a difficult question, I realize, but have you considered, has the FDA considered that perhaps different endpoints should be considered in terms of granting an EUA in the future as new vaccines apply for an EUA? Over.
Thank you for your question. You know, the endpoint is a clinical endpoint because in the absence of an immune correlate of protection, the standard is the clinical endpoint. So so far that hasn't changed, and with the continuing monitoring, we will be able to assess the efficacy of the vaccine, the duration of efficacy, and the efficacy against new circulating strains. And we are engaged in several conversations to implement strategies to monitor and address the issue of variants that are circulating. And I think that we will hear more in the next two presentations about that.
Thank you.
Thank you.
Thank you. Dr. Chatterjee, please.
Dr. Allende, thank you very much for your presentation as well. I have a question regarding the sponsors applying for a BLA. What is the timeline, expected timeline for the sponsors that are receiving authorization under an EUA to apply for a BLA for these vaccines?
Our recommendation and expectation is that the follow-up should be as long as possible given all of the circumstances that might affect the participants' time during the study in the follow-up with the availability of other vaccines. However, we expect, if possible, a follow-up of 6 months, a total follow-up of 6 months for safety and effectiveness, with several strategies to address those issues of unblinding and placebo crossover, to retain as much as possible the participants in the study.
Thank you.
Dr. Levy.
Dr. Allende, thank you for that excellent presentation. A general question about FDA guidance for future EUA for coronavirus vaccines.
you. Now, international people, I know. All right. I'm gonna, once I hear everybody, hold on a minute. We're gonna let everybody. Glenn. All right, welcome back. All right, we just had a quick little opportunist break there just to get some audio issues. Welcome back to our 164th VRPAC meeting. Dr. Monto, you want to pick up where we left off?
Well, I finally got on again, so yes, it's my pleasure to introduce Dr. Adam McNeil, who is from the Division of Viral Diseases at the Center for Disease Control and Prevention, who will be talking to us about a very important topic, epidemiology of COVID-19 variants.
Hi, good
Dr.
morning.
McNeil.
Hi, good morning. I'm Adam McNeil. So I'm with the Division of Viral Diseases at CDC, and I'm a representative on the Epidemiology Task Force as part of the COVID-19 response at CDC. So I wanted to start first by giving a brief overview of our current global situation with SARS-CoV-2. Currently, there's been over 110 million confirmed cases of SARS-CoV-2 with almost 2.5 million deaths. The bulk of the burden has been in the Americas and the European regions of the world. And we are seeing positive trends in the right direction in terms of declining cases, although I would note that these spikes have occurred at various times in various regions. So I think we remain relatively concerned about the current epidemiologic situation. So I'm going to talk about the various variants of concern. I want to briefly talk about what constitutes or what are the criteria for defining variants, including variants of interest and variants of concern. Currently, various organizations are developing standardized definitions. This includes WHO. From the United States government standpoint, we have a definition that's currently being reviewed as part of interagency activities, and we hope to have that finalized soon. But in general, regardless of the formal definition, there are some key criteria that generally meet consensus for helping define particularly a variant of concern. And this concludes at least one of the following: evidence of immune escape, either due to vaccine or natural infection, evidence of convergent evolution, impact of the variant on diagnostics, impact of the variant on therapeutics, evidence of increased transmissibility, or evidence of increased disease severity. For this presentation, I'm going to focus on the epidemiology of three specific variants, which currently have general consensus as being characterized as variants of concern. These variants are the B.1.1.7 variant, which was first identified in the United Kingdom and likely emerged in September of 2020. The B.1.351 variant, which was identified first in South Africa around October of 2020, and the P.1 variant, which was first associated with Brazil and Japan and identified in January of 2021. Notably, all three of these variants have two distinct amino acid changes, N501Y and D614G. Importantly, the emergence of these same amino acid changes in all three of these variants is suggestive of convergent evolution, in other words, suggestive of a potential selective advantage. In addition, the B.1.351 and the P.1 variants have a notable amino acid change of E484K. And this amino acid change has been very much associated in vitro with very strong evidence of reduced neutralization to previous infection as well as vaccination. In addition, I want to note one characteristic of the B.1.1.7 variant that's relevant to some of the current data we have. This contains a deletion at amino acids 69 and 70 of the spike gene, which impacts the S gene on multiple diagnostic PCR assays, which results in what has been referred to as an SG target failure, or SGTF. Due to this distinct pattern, it's allowed as an effective tool for screening or potentially enriching for identification of B117 using PCR assays. So since transitioning specifically to B117, since being identified in November 2020, B117 has rapidly been broadly identified across the globe. Notably, there's a high density and a high overall number of cases of infection of this variant in Western Europe, particularly in the United Kingdom. Though I would caution when we look at this distribution that in many parts of the world, actual coverage with sequencing is relatively limited. So we have to realize this probably does not represent the full distribution of B117. Relatedly, if you look on the table on the right, you can see that in many countries in Western Europe, B117 has actually become the predominant virus in circulation. So as mentioned, B117 was first detected in England of 2020 and likely actually emerged in the southeast part of the country in September of 2020. The United Kingdom has used the S gene target failure PCR pattern as a way to actively monitor spread of the variant. And we observed in late 2020 a very rapid expansion of this variant throughout the United Kingdom. Based on various modeling studies, it has been estimated that the reproductive number of the B117 variant is approximately 1.5 times higher. Or in other words, this data suggests that B117 is about 1.5 times higher in terms of transmissibility in comparison to the previous dominant variant. I also want to briefly touch on the evidence suggesting potential increased severity of disease associated with B117. This data is pulled from a previously this evidence is pulled from previously unpublished data that was reviewed by the New and Emerging Viruses Threat Advisory Group in February 2021. And it was based on a composite analysis of 22 different related analyses or studies. And the data used a combination of either B117 confirmed variants based on sequencing or data using the S gene target failure marker. Based on review of all the evidence, it was concluded that there was evidence from these analyses of multiple different data sets that have infection with B117 that is associated with an increased risk of hospitalization and death compared to infection with non-variant of concern viruses. Results, if you look at this preliminary report, varied, but some outcomes were statistically significant, with ratios of hospitalization and death up to 1.7 times higher for this variant as opposed to baseline viruses. However, it should be noted that one of the key conclusions of this report is the absolute risk of death per infection remains low even with B117. Moving on, I want to talk a little bit about the global distribution of the B1351 variant. This variant was first identified in South Africa in October of 2020, and South Africa continues to have the highest case counts. Although, like I mentioned previously, I caveat this by the fact that many countries currently have limited sequencing coverage. You can see that in addition to South Africa, multiple countries in the southern part of the African continent have had cases identified. Similarly, there are a number of cases that have been identified in Western Europe, and a small number of cases have been reported from the Americas, Asia, as well as Australia.
Looking at this variant, specifically using one case study, a recent MNWR report documented the potential epidemic spread of B1351 in Zambia. This figure demonstrates the trend in the overall number of confirmed COVID-19 cases in Zambia. Starting in December, as you can see, a large spike in overall case numbers was noted within the country. Sequencing performed on a selection of diagnostic specimens from mid-December identified a high proportion of the B1351 variant, with 22 of 23 specimens being this variant. Notably, these specimens were obtained from 4 different provinces, indicated likely broad or wide distribution of this variant throughout the country. Similarly, prior to December, no B1351 cases were identified among 245 specimens that were previously sequenced within the country. Moving on to looking at the global distribution of the P1 variant. This virus was first identified among travelers from Brazil in January of 2021, and Brazil really remains the epicenter of transmission, which I'll discuss more in the next slide. Additionally, this variant has been identified in North and South America, Western Europe, and there are a small number of cases that have been documented elsewhere. So I'd like to turn over to the Manaus region of Brazil, which presents interesting and I would say quite concerning situation. There was a wide, largely unmitigated outbreak of COVID-19 that occurred within the Manaus region of Brazil in mid-2020. And you can see on the figure A, on the upper half of this, the large peak in excess mortality that occurred within this region of Brazil in 2020. A study used blood donor serology to estimate the actual seroprevalence of SARS-CoV-2 in Manaus, an estimated seroprevalence in October of 2020 to be around 76%. Notably, even with waning immunity, one would expect that this highest seroprevalence would likely have put this region in the position to be able to establish herd immunity. However, a second large peak in hospitalizations and excess mortality began being documented in January 2021, as you can see on the far part of figure A. P1 variant was detected in circulation in Manaus in January 12, 2021. And as shown in the previous slide, this really represents kind of the epicenter where now numerous instances of P1 have been detected in this region. Well, waning immunity from the previous large outbreak may partly be contributing to this overall second spike. I think it's important to point out that largely this data is probably suggestive of a certain degree of antigenic escape associated with P1. I would note that a number of further investigations are currently going on to better understand the situation within Manaus. I'm going to turn over to the SARS-CoV-2 situation in the United States now. As of earlier this week, we're hitting around 70,000 new cases being reported on a daily basis. This is down from a peak of over 300,000 being reported on a daily basis, which occurred in December and January of last year and earlier this year. In total, almost 28 million cases of SARS-CoV-2 have been reported within the United States. So as you can see from the curve on the right side of the slide, we are moving in the right direction with certainly a strong downward trend in the number of cases. However, I would caution we are certainly not out of the woods yet, and we need to continue our focus on mitigation measures and trying to stop the current outbreak. So as I get into talking about some of the approaches we're taking towards genomic epidemiology within the United States, I want to talk about how we're thinking about this in terms of key objectives and approaches. This can broadly be grouped into 3 categories. First of all, using genomic epidemiology for situational awareness or surveillance. So this would be to understand the prevalence and spread of variants and potentially use this for broader public health decisions. I would mention that for surveillance and situational awareness, this does require widespread sampling of representative specimens for sequencing, and the overall number of specimens is largely dependent on the burden of infection. Second is using genomic epidemiology to allow for novel variant detection. This the main focus of this is to identify the presence of novel variants for further investigation. And as I'll talk about in a later slide, this is more focused on using a relatively fixed sample size within a defined population for detection of variants. Finally, we are using genomic epidemiology for focused studies. This includes trying to better understand the transmission, clinical outcomes, and vaccine effectiveness associated with variants. And for these studies, it requires extensive sampling and sequencing within a targeted population. So I do also want to touch on some of the inherent challenges of using genomic epidemiology to characterize SARS-CoV-2. First of all, in our current situation, we have to acknowledge that only a small proportion of viruses are being sequenced. And as I'll touch on, we are really rapidly scaling this up, but the reality is even if we can get to extremely high numbers with current incidents, we may only be sequencing 5 to 10% of specimens. So the reality is that we can have a certain degree of evidence, but we may not ever know the full situation in terms of what is going on with the virus. Second, there is an inherent time lag between sample collection and sequencing results. And while we are trying to push this time lag down, it does remain a significant challenge. So thus far, sequencing is not a rapid diagnostic tool. It has limited current utility from a clinical standpoint for clinical monitoring. And it currently represents a challenge for informing immediate public health action. Oftentimes, by the time we are ever able to actually confirm a variant, it may be late in terms of the opportunity for conducting contact tracing. I'd also like to note that we have not yet demonstrated sequencing as an effective containment strategy, and this is just evidenced by the fact that we have seen broad global spread of these 3 SARS-CoV-2 variants that I've discussed. Finally, sequencing by itself has limitations in terms of predicting epidemiologic outcomes. So key to mention that sequencing needs to be linked with supporting virologic and immunologic studies, as well as clinical and epidemiologic data. And acquiring clinical and epidemiologic data does take substantial sample size numbers and often takes a decent amount of time to fully characterize. So going on and looking at what sample sizes are needed to actually detect variants of concern. So this approach was adapted from the influenza virologic surveillance right-size roadmap, which has really been our long-term approach for estimating sample sizes for influenza surveillance. So this represents a disease-agnostic sample size calculator. And I would note that various factors, including the actual sampling strategy, variant prevalence, and turnaround time can affect actual numbers. But to give a rough sense in terms of numbers needed, if we want to have a 95% chance of identifying a variant that occurs in 1 out of every 1,000 cases, so in other words, a 0.1% prevalence, we need approximately 3,000 sequences per week. And if you look at the figure I noted, as prevalence increases, so as we get up to 1% prevalence and 5% prevalence, this actual number needed to sequence becomes smaller. So as prevalence goes up, the number of sequences needed to detect a variant decreases.
So we are currently taking a number of different approaches to evaluate genomic epidemiology of SARS-CoV-2. First is really kind of our backbone surveillance program, which we call National SARS-CoV-2 Strain Surveillance, or NS3, which represents a random selection of specimens submitted by public health laboratories for sequencing at CDC. In addition, we're taking further efforts to scale up sequence numbers by partnering with commercial diagnostic laboratories, conducting focused epidemiologic studies, developing contracts and partnerships with state and local health departments and universities, and finally by supporting the VIRS consortium, which represents a consortium of over 160 partners that are working to standardize metadata and ensure that there is a large number of SARS-CoV-2 sequences available in the public space. So going on and looking at sequences in the public repository. In this slide, I'm showing numbers of sequences from specimens in the U.S. currently available in public repositories. And you can see in the orange line the number of sequences from the United States that have currently been submitted to GISAID, which is currently around 100,000. And we do hope that this will rapidly continue to increase as we are scaling up our sequencing efforts within the United States. Further, I want to note that we have a number of pre-existing protocols and study platforms that we are currently adapting to try to better understand epidemiologic and clinical characteristics of the viral variants. And this is, being able to use these platforms is somewhat dependent on the prevalence of a variant. So to be able to pull out clinical characteristics of a variant with very low prevalence is challenging. But as we continue to see increasing proportions of all cases that are represented due to variants, we anticipate having further statistical power to be able to tease out various epidemiologic characteristics. Furthermore, I would note that we are conducting surveillance and investigation of vaccine breakthroughs to understand the actual impact that viral variants have on occurrences of vaccine breakthrough. So looking at actual current numbers of SARS-CoV-2 variant cases detected in the United States, currently there are approximately 1,600 reported cases of B.1.1.7, 22 cases of B.1.351, and 5 cases of P.1. And you can see from these maps the current distribution of these cases. I would note that due to sequence coverage, as well as looking at the distribution, that these variants are probably much more widespread throughout the country. And I think we have to assume, in the absence of other information, that these variants probably could exist throughout the entire United States. So in order to better understand the potential impact of B.1.1.7, assuming increased transmissibility of this variant, we developed mathematical models to look at the dynamics of viral transmission. In this slide, 2 scenarios are shown. In the figure on the left, a baseline reproductive number of the dominant virus is 1.1 is plotted. And in the right, we use the scenario of a reproductive number of the baseline variant or baseline virus as 0.9. The incidence of disease is shown on the y-axis. In both scenarios, B.1.1.7, as represented in light purple, eventually becomes the dominant virus in late to mid-March. While these are theoretical models, even with a lower reproductive number, which may be closer to the current epidemiologic situation, B.1.1.7 does eventually result in an overall uptick in case counts. So in these figures, we have used the same modeling assumptions as the previous slide. However, vaccine introduction is additionally added to the model. As with the previous scenario, B.1.1.7 becomes the dominant virus in mid to late March. However,
through scale-up of vaccination, the actual trajectory of case count is substantially blunted. I would similarly like to briefly pull in some empiric data from a combination of academic partners and a commercial diagnostic laboratory that looked at early introduction and spread of B117 and specimens being submitted through their diagnostic network. Based on their evidence, they noted that B117 likely arrived in the United States in November of 2020, and multiple introductions occurred. Geographically, B117, based on current data, is widespread and confirmed in 44 states. This data from early February estimated prevalence around 1 to 2%. However, when the actual trajectory of the increasing prevalence was plotted through January and early February, it did appear that the virus was at an exponential growth phase if you look at the proportion of cases due to B117. So this is also supportive of the notion that B117 is on a trajectory to potentially become the dominant variant within the United States. I want to move on and look at the overall burden of infections within the United States so we can think about the impact that viral variants may have on this. We have started conducting routine seroprevalence surveys using commercial diagnostic specimens starting in around June or July of this year, which we use to generate seroprevalence estimates every 2 weeks for all states within the United States. So in this slide, I'm showing our seroprevalence estimates from December of 2020. And you can see from this slide that many states are starting to approach close to 25% seroprevalence. I would note that seroprevalence may underestimate the overall burden of infection because of potential waning in immunity. So we have similar used probabilistic models to try to account for under-detection and under-reporting of infections and estimate the overall burden of infection. Through December of 2020, based on these models, it's been estimated that over 83 million infections have occurred within the United States, with 70 million estimated symptomatic illnesses and 4.1 million hospitalizations. So if you look at this number, 83 million infections, it would land on approximately 25% of the U.S. population previously being infected with SARS-CoV-2 by December of 2020. So how do these estimates stand with regard to herd immunity? So shown in this slide is a figure generated by Omer et al. Using empiric data to estimate herd immunity requirement of SARS-CoV-2. So based on estimates of the reproductive number, approximately 60% population immunity is necessary to establish herd immunity. So based on our current estimates, which I showed in the previous slides, through around December 2020, we're certainly nowhere close to having herd immunity. Would note since this time, obviously, vaccination has started, and hopefully this is moving us closer to filling the herd immunity gap. However, thinking about the potential impact of variants on viral transmission and population immunity, currently we know that the U.S. population, the majority of the U.S. population is not immune to SARS-CoV-2. And variants may affect, may cause this proportion of the population that is not immune to increase. Waning immunity has potential to continue to contribute to this pool of individuals who may be susceptible to infection or disease. Increased transmissibility of a viral variant would require higher proportions of the population to be immune to establish herd immunity, and decreased effectiveness of a vaccine to protect against infection by a variant virus could result in prolonged or continuous transmission of SARS-CoV-2. So if I wrap this up, I want to talk about some key public health messages to stress. First of all, we know that current mitigation strategies work, and they work against variant viruses. So this includes masking, social distancing, hand washing, quarantine, and public health policies. Variants demonstrate the need to push, further push these mitigation measures. current epidemiologic data is moving in the right or downward direction. However, potential of increased transmissibility means that adherence to these mitigation measures needs to be higher in order to maintain this downward trend in cases. Additionally, I will stress the importance of vaccination and monitoring the impact of vaccination. Vaccination provides general protection for the population against SARS-CoV-2. The impact of viral variants on vaccine effectiveness is still being characterized, but even with decreased effectiveness, vaccination still may provide partial protection against variants. And this underscores the need for robust epidemiologic and virologic surveillance system to determine if vaccine updates are needed. So in conclusion, 3 variants of concern have currently been identified. As SARS-CoV-2 continues to evolve, we have to figure inherently additional variants will likely emerge. And this underscores the importance of genomic surveillance. Data suggests that variants may have increased transmissibility, increased severity, or the ability to evade immune responses from previous viral infections. Epidemiology indicates broad global spread of these variants, and containment of variants has thus far been unsuccessful. And finally, this underscores the importance of currently well-characterized mitigation measures. This includes use of well-fitted masks, hand hygiene, social distancing, avoiding crowded or poorly ventilated indoor spaces. And finally, focusing again on ensuring we scale up vaccination to all those who are eligible to receive the vaccine. Thanks, and I would be glad to answer any questions you have.
Thank you, Dr. McNeil. Very important presentation for the rest of our discussion. Dr. Rubin.
Thanks, Dr. That was very interesting. When it comes to specifically to the vaccines and their efficacy, the concern, of course, is pre-existing mutations that increase efficacy and perhaps the appearance of new mutations in the vaccinated population because of the new selective pressures. And it seems to find those, you'd have to be systematically sampling the escape mutants, and that means rather intensively, and have a representative sample of the population to compare that with. So the I wonder about that about both those pieces. Are we systematically sampling escape mutants? And the 3,000 say sequences we're getting a week of that we're getting right now, are they in any way? Do we know they're representative?
Yeah. Thank you, Dr. Rubin. I think first, touching on this representative piece. So the underlying goal with the NS3, so the 3,000 specimens, is to be broadly representative. As we're standing this up, the proportion of specimens that we're receiving from state and jurisdictional labs is proportional to their representative population size. And we are requesting that these states and jurisdictions try as best as they can to submit random specimens. I would add on the commercial laboratory front, as we are scaling up the number of sequences being generated by commercial labs. Early on, a lot of the sequencing was focused on the S-drop pattern and trying to identify B117. We have shifted this to have our contract focus more on having large commercial laboratories doing random specimen sequencing. So we actually hope to be able to get relatively large numbers to have a representative set of specimens. But, you know, it does remain an ongoing challenge. And, you know, I think inherently we can never hope to be perfectly representative, but I think we are getting relatively close to what we need to be able to have a representative denominator and actually understand what the virus is doing in terms of background circulation. Regarding systematically looking at
viral breakthrough. I would note a couple things. Both CDC, but largely more in the interagency space, we are actively working to combination of acquire and culture variants of concern as they arise, as well as collect and characterize immunological breakthrough using sera from previously vaccinated individuals. In addition, we have a currently established protocol, and we are currently conducting more passive, but from a somewhat active standpoint, also trying to acquire and characterize instances of vaccine breakthrough. And hopefully by evaluating those, both looking at the viral sequence as well as hopefully being able to acquire serologic samples from some individuals who are incurring vaccine breakthrough, will continue to better characterize these instances.
Okay, thank you. Dr. Gantz.
Thank you so much. You started, this has been a really helpful, informative, thoughtful, and very important discussion. So thank you for bringing this to the forefront. You started to allude to some of the efforts that you're doing to understand breakthrough, and I was very glad to hear that you're actually trying to get some samples, some blood samples from the vaccine. This is a group of people, obviously, that is very well characterized, and so it's an opportunity. You talked about serologic. Can you just discuss a little bit more about the immunity studies that you're going to undergo in terms of how you're looking at this? Because I think what we're starting to see is some discordance in the humoral and T-cell immunity in some of these people. And so to understand that a little bit better, it'd be nice to know how that pattern is being evaluated, particularly as it pertains to these variants.
Yeah, thanks. A great question. And I am going to caveat this because I am not working on the laboratory end. But, you know, from a broad standpoint, certainly a number of in vitro studies have focused on the serologic component and looking at correlates of breakthrough from infection. From a T-cell standpoint, you know, I know this is an area that's been discussed. Obviously, characterizing T-cell responses and even acquiring specimens from a relevant number of individuals is more challenging from a serologic standpoint. But I know that that is an area that there's also interest. I think we're looking at this from a broad perspective. I would use probably the closest analogy is how we continually characterize influenza and the dynamics between that virus as it's circulating and the vaccine. And I would note this is a combination of CDC as well as a number of other organizations in the interagency space, including NIH, FDA, DOD.
Dr. Meisner.
Thank you. I'll add my compliments for a very clear, helpful presentation. I would like to ask you a little bit about serologic correlates of immunity and how that's going to be impacted by these variants. It would be nice if a serologic correlate of immunity could be established so that large efficacy trials, which are so expensive and so time-consuming, weren't necessary. And particularly thinking about children. If we had a serologic correlate of immunity, that might make it easier to evaluate vaccine usefulness in the pediatric age group. But it seems to me it's going to be hard to establish a serologic correlative immunity if these variants continue to emerge, because the threshold of immunity will probably vary depending on the vaccine and depending on the variant that's circulating. So perhaps you could comment on that.
Sure, thanks. Great question. You know, I think the issues with the variants underscores that exact concern. You know, I think we've seen, and I realize those on this call know the clinical trial data better than I do, but you know, we've seen, particularly with B1351, that there's a lot of evidence that the vaccine does not provide as high levels of serologic protection. So as these viruses are evolving, it may be a moving target in terms of what the serologic correlative protection is. You know, going back to the E484K amino acid change, you know, I think that was the one. It's been, I would say, there's been a logical scientific progression where around December, January, there was antigenic mapping, and this was, in essence, the amino acid that showed the highest potential for immune evasion. And then I think we've seen analogously evidence of, as this mutation has been present in both B1351 and P1, there's similar evidence. So I think there is a certain alignment between the in vitro studies and what we're seeing in vivo, but it is probably going to be a moving target. I think that's going to be one of maybe the fundamental questions as this outbreak progresses is how is this virus going to behave? Are we going to need annual updates like influenza? Will we need annual updates every 5 years, or will we have broad enough protection to be able to use, in essence, a steady state vaccine?
Thank you.
Thank you, Dr. Meisner, and thank you, Dr. McNeil. I'm going to have to close the question period right now. This is a topic which we are going to be returning to in our open discussion this afternoon. So please, if possible, stay around so we can follow up with additional questions at that point. Now, I'd like to move to another issue, post-marketing surveillance from currently authorized COVID-19 vaccines. This is going to help us decide on what is working and what is not working. And we have a double-barrel presentation, first from CDC, Dr. Shimabukuro from CDC, who is Deputy Director of Immunization Safety Office, and then from FDA, Dr. Stephen Anderson, who is the Director of the Office of Biostatistics and Epidemiology, and we'll have the two presentations in sequence and the question period following. Please go ahead.
Thank you. This is Tom Shimabukuro. Can you hear me okay?
We can.
All right. Good morning. Today I'm going to do an update on VSafe, one of our CDC's safety monitoring systems, then a vaccine adverse event reporting system update, a vaccine safety data link update, and then I'm going to spend some time focusing on COVID-19 vaccine safety in pregnancy. Starting off with VSafe. So just to remind folks, VSafe is our smartphone-based text and web survey monitoring system that CDC stood up just for COVID-19 vaccines, the COVID-19 vaccination program. It involves health check-ins that occur daily, the first week after vaccination, and then weekly, and then through 6 weeks, then 3, 6, and 12 months, and the process starts again when a person gets a second dose. It's a voluntary self-enrollment program. If on any health check-in, a a registrant reports that they receive medical care, we will follow up through our call center with VAERS and take a VAERS report. The questionnaires also allow for identification of pregnant women, and we also have a pregnancy registry team that conducts follow-up for enrollment into the pregnancy registry. So as of February 16th, that's the analytic period that, for this presentation. There are roughly 55 million individuals who had received one or more doses of COVID vaccines in the United States. And we had about 3.9 million registrants in VSafe that had completed at least one health check-in. And that included just over 30,000 individuals that self-reported that they were pregnant on a VSafe health check-in. So this table is from an MMWR that was recently published, and I apologize if this is a little bit small, but the analysis that I want to draw your attention to is really looking at dose 1 versus dose 1 for the two vaccines, the Pfizer-BioNTech vaccine and the Moderna vaccine. And specifically, we're looking at reactogenicity, which is collected during week 1 following vaccination, of dose 1, day 1, of Pfizer versus dose 1, day 1 of Moderna. And you can see that the reactogenicity profiles are very similar. Injection site pain is commonly reported, and then systemic reactions are also commonly reported as well. Confirming what was observed in the clinical trials, these mRNA vaccines are reactogenic, and the reactogenicity profiles of the two vaccines for dose 1, day 1 look very similar. Then at the time of this analysis for the Pfizer-BioNTech vaccine, we had some dose 2 data. We didn't for Moderna because of the timing of the rollout and the longer period between doses. But for the Pfizer vaccine, we had information on dose 1, day 1 compared to dose 2, day 1. And if you look at the comparisons for the systemic reactions like fatigue, headache, myalgia, chills, fever, joint pain, nausea, there's substantially more self-reported reactogenicity symptoms for dose 2 compared to dose 1, up to 3 to 4-fold higher in some cases. And that's not unexpected. That was observed in the clinical trials. So the VSafe reactogenicity really kind of confirms the safety profile of these vaccines and confirms that it was similar to what was observed in the pre-authorization clinical trials. Moving on to VAERS. VAERS is our spontaneous reporting or passive surveillance system that's co-managed by CDC and FDA. VAERS is a national system. Basically, anyone who's eligible for a vaccine is in the covered population. It can rapidly detect safety signals and can detect rare adverse events. The main limitation of VAERS is that it is not designed to assess causality. It accepts all reports from anyone, regardless of the plausibility of the vaccine causing the event or the clinical seriousness of the event. It's a hypothesis-generating system to identify potential safety concerns or signals that can be studied in more robust data systems. So at the time of the data cutoff for this analysis, which was February 16th, we had just over 100,000 reports to VAERS, of which 94% were non-serious and 6% were serious. Serious uses the regulatory definition. So here's two tables showing the most commonly reported adverse events to VAERS for the Pfizer-BioNTech vaccine on the left and the Moderna on the right. You can see that systemic reactions and local reactions are the most commonly reported adverse events. But importantly, there were no empirical Bayesian data mining alerts detected for any adverse event COVID-19 vaccine pairs as of the last data mining run that FDA performed on February 18th. I just want to draw your attention to a fairly recent publication which updated some of the anaphylaxis reporting rates for the vaccines. This is a little small. I've highlighted a statistic on the bottom there showing that the most current reporting rates we have for the for anaphylaxis were 4.7 per million doses administered for the Pfizer-BioNTech vaccine and 2.5 per million doses administered for the Moderna vaccine. So I think the take-home message here is that these are rare events, and anaphylaxis, although clinically serious, is treatable, and there is CDC guidance available on identifying, managing, and being prepared at vaccination locations to handle anaphylaxis when it occurs. Moving on to the vaccine safety data link. It's a collaboration between CDC and 9 participating integrated healthcare organizations. It has electronic health record and administrative data on a covered population of roughly 12 million persons per year, and it also has rapid access to charts to review to confirm cases if need be. As of through February 13th, there had been approximately 630,000 doses, dose 1 doses of any COVID-19 vaccine administered in VSD, and about 200,000 dose 2 doses. We do something called rapid cycle analysis in VSD. These are basically weekly analyses of the data as the data accumulate. And I'm showing this slide mainly as a reference slide. This shows all of the pre-specified outcomes for VSD rapid cycle analysis. These are outcomes that we've identified in advance and we are monitoring. The analysis I'm showing here is an unvaccinated concurrent comparator analysis. That's basically comparing vaccinated individuals with unvaccinated individuals for these adverse events, and they're matched on certain characteristics, vaccinated and unvaccinated individuals. The preliminary results of the unvaccinated concurrent comparator analysis after any dose of an mRNA vaccine showed no statistically significant increased risk detected for any of these pre-specified outcomes. So what I'm showing here is a different kind of analysis. This is a sequential vaccinated concurrent comparator analysis. This is comparing vaccinated individuals and looking at events in the risk interval versus events in control interval. And I'm only showing outcomes for which there are events in the risk window. So if you don't see an outcome on here compared to the previous slide, that means there was just no event in the risk interval. And the preliminary results of the sequential vaccinated concurrent comparator analysis was that there were no statistical signals detected. So next steps for VSD RCA, we're going to do a dose-specific analysis, product-specific analysis in 2 risk intervals, 1 to 21 and 1 to 42 days, and a historical comparator analysis that's expected to start in the latter half of March. Moving on to pregnancy, the VSAFE pregnancy, VSAFE participants who self-report pregnancy are actively contacted and enrolled. The outcomes of interest include fetal demise, pregnancy complications, maternal intensive care unit admission, adverse birth outcomes, neonatal death, and infant hospitalizations, and major birth defects. So we have currently enrolled just over 1,800 individuals in the VSAFE pregnancy registry. Moving on to VAERS data. As of the 16th, there were 154 reports to VAERS. And there were, the median maternal age in these reports was 33, median gestational age 13. Just over half of these reports involve vaccination in the first trimester, and you can see the vaccines there below. Of these 154 reports, most of these, and in fact 73%, were non-pregnancy specific adverse events that you would expect, like headache, fatigue, chills, local reactions. Of the 42 pregnancy or neonatal specific conditions, most were spontaneous abortion or miscarriage. I just want to point out that the frequency of spontaneous abortion and miscarriage is actually quite common, 10 to 20% based on age. So there are other maternal vaccination safety activities, which I'm not going to cover in detail, but they include studies and surveillance activities in VSD and in the Clinical Immunization Safety Assessment Project. So to sum things up, as of February 16th, just over 55 million doses had been administered in the United States. The reactogenicity profiles of the mRNA vaccines in VSafe are consistent with what was observed in the clinical trials. Systemic and local reactions are most commonly reported to VAERS. Anaphylaxis does occur, though rarely, and there's no safety signals for any serious adverse events. And there are no safety concerns identified among VSD rapid cycle analysis outcomes. Most reports to VAERS among pregnant women involve non-pregnancy specific adverse events. Miscarriage is most frequently reported. The most frequently reported pregnancy-specific adverse event, but the number was not concerning considering expected background rate. And safety monitoring in pregnant women is ongoing or planned in VSafe, VSD, and CISA. Thank you. That concludes my presentation.
All right, I'm going to just give an update on FDA's monitoring of the COVID-19 vaccine safety and effectiveness work that we're doing. So Tom has presented information from this slide. Just wanted to note the 55 million doses administered. We're using the same set of numbers for our presentation. Since Tom has already this is a slide of our current vaccine surveillance programs, and since Tom has already covered the passive surveillance and VAERS systems, I'm not going to cover that. I'm really going to focus on the bottom portion of the slide, the active surveillance component, talking about our CMS work, our work on background rates, our work on study protocols, and then talk about next steps. So just launching into the FDA CMS work, we're going to talk about our rapid cycle analysis, specifically talking about the approach, which is to monitor 20 or more outcomes, which Tom sort of mentioned in his presentation. FDA is identifying the elements of our RCA we're identifying and using 15 possible adverse events of special interest. I wanted to then talk a bit about getting sufficient counts in the CMS database to start the analysis, the background rates, and then talk about where we are as far as conducting the RCA analysis and CMS data. So these are the adverse events of interest that FDA is focusing on. I just wanted to mention that these have been studied in other vaccines, but they haven't been associated with the COVID-19 vaccine in pre-authorization studies. So some of the things you've seen in previous studies, like Guillain-Barré syndrome with Bell's palsy, et cetera. I just wanted to talk about the rarity of these events, 1 in 10,000, 1 in 100,000 or less, and so they're rare. And so need large databases in many cases in order to get significant power in order to analyze these with millions, usually with millions of patients. The CMS data, just to remind people, I think I've shown this slide at the previous presentation to this committee. The data covers nearly all of the 55 million elderly U.S. beneficiaries over 65 years of age in the United States. All right, so here's the counts that we're getting. So in the CMS Medicare data, we've got 4.8 million total doses. And just to sort of orient you on the graphics, the far left, this bar is the total number. The middle is the first dose. The right bar in the set is the second dose. And as you can see, for Pfizer, there's 2.8 million doses and 2 million doses for the Moderna vaccine. And the time period given for this analysis is listed in the bottom left corner. All right, so as far as those vaccine counts, what does the age distribution look like? So this is just a check, and so you can see that most of the counts end up in the age 65 years of age and older. Medicare does cover younger populations, persons with disabilities, and kidney disease, and so so you'll see some of those represented in the lower age populations in this study.
All right, so background rate analyses. So background rates, why are we talking about them right now? So the background rates for AESIs provide us with information on expected rates or an estimate of baseline for comparison to see if there's an elevated risk of for an AESI, then we need to compare that to some sort of baseline historical number. So for our analysis, I think it's important to mention that COVID-19 vaccines are new, so we lack kind of that historical information that you might have for a vaccine like influenza, where we have years and years of data where we can understand background rates for these AESIs. But what this work does in the third bullet point is really requires us to go ahead and generate new background rates for the selection of comparator groups. Just going down to the bottom bullet point, so we've actually generated information on background rates for 4 different populations. And I'm sorry this type is small, but what we've done is we've looked at, in the CMS data, at the population overall, the age 65 years of age in that group. And then we've also looked at influenza vaccinees age 65 years of age and older and gotten the rates for those specific AESIs in that population. The time periods may be important too, so we've looked at that. So we looked at the pre-COVID period, and that means for the years 2017, 2018, and 2019, and that should give us information prior to COVID. And then we're also looking at the peri-COVID or sort of the COVID period, which we think is another important consideration. And why are we doing that? Well, so in the first bullet point here, the COVID-19 pandemic may have impacted healthcare utilization, and that's been published in the literature that for like infections like, for conditions like heart attacks or AMI, reports dropped initially by 50% in the first few months of the pandemic, and then initially rose back to sort of more pre-pandemic levels. So that's of interest to us if we're trying to evaluate what's the relevant background rate to use for the analysis. So we've assessed background rates in these populations, and what I wanted to show you was some of the results, and these are just sort of representative. So the top 3 lines on this left graph represents 2017, 2018, and 2019. And then this is for colonoscopies, and as you can see, and you might have expected this, but during the first few months of the pandemic, colonoscopies dropped by almost 75 or 80%. But then by about September of the fall, they started to climb back up to rates that were equivalent to prior to the pandemic. Now, if we look at something like stroke in the graph on the right, you can see again those 3 lines in blue, orange, and gray sort of show you that the rates for 2017 through 2019, and by comparison, the line in yellow, you can see there's a dip. Again, similar to what colonoscopies, but not so, not such a strong relation, not such a strong drop for hemorrhagic strokes. And then what you can see is that it's really popped back up by late summer to sort of the pre-COVID rates. So what does that mean for us? So for a majority of the ASIs in our analysis, we selected the pre-COVID-19 background rates among persons 65 years of age and older in our CMS data. For a few of these ASIs, like less than 5 of those AESIs, where the rates didn't recover, then we used the pre-COVID-19 levels for our background rates. And then just to note, the background rates are also being standardized against for age and other demographic characteristics. So I just wanted to talk about where we are as far as our RCA analysis. The FDA's done this foundational work on the counts monitoring and then the background rates, and that work is complete. So we just sort of started to on the preliminary runs. Those have been underway for the last few days. And we're evaluating our early results. So our expectation is we'll have results probably end of the week, early next week, into the weekend. And then our expectation is to be able to sort of fine-tune our analyses and then conduct runs every 1 to 2 weeks to kind of achieve our goal of near real-time monitoring of safety for these 15 outcomes. I just wanted to mention that we have these surveillance study protocols that sort of support the work that we've done. The first bullet points we've done looking at the background rates, as I've mentioned. The second protocol that we've done is the active monitoring, which is really just describing the rapid cycle analysis protocol used. Each of those protocols were posted on the bestinitiative.org website. And so we received comments for about 10 days on each of those. And then I think we posted the latest version or the latest update on February 10th and 11th. So you can go to that website and see those. We're also developing additional protocols for inferential studies. So if we do signal in these RCAs, we need to follow up with epidemiological studies, and the goal would be to these protocols have those protocols listed that we would be using to follow up on any signals identified in the rapid cycle analysis or any signals identified in bears like the anaphylaxis and others. There's also testing where we're evaluating the performance of testing codes as well, and that protocol is under development as well. And I just wanted to say sort of at the bottom of this point number 2 is we're developing a vaccine effectiveness study, and obviously many considerations there. For instance, effectiveness by vaccine, comparative effectiveness by dose, duration between doses, duration of protection, and a number of other factors for considering and developing those protocols. And then just to get to the next steps, I wanted to say that we talked about persons 65 years of age and older. What we need to do then is focus on 18 to 64-year-old persons. And we're going to be conducting additional rapid cycle analyses. And if you go down to the bullet points in the middle here, we're going to be doing these analyses in Optum and then CVS Healthagen. And that should cover approximately, I think, 25 to 30 million persons overall is our hope. And then to add other claims databases as soon as we can bring those online. And our plan is we would start analyses in late March for the 2 databases listed, followed by in subsequent weeks with other databases. And again, I think Tom mentioned what they're doing by brand. They're analyzing their ASIs by brands, by risk intervals, doses, et cetera. I just wanted to mention quality assurance. So I think the power of the government approach is that we're able to compare our results that we get with the FDA systems with those of the CDC's VSD, but also the Veterans Administration is running similar analyses. So we can do this cross-comparison, see what we're getting. If one gets a signal in their system that others don't get, we can do validation of those outcomes and verify signals that are identified. And then I just wanted to acknowledge that this work is a huge amount of work by a number of colleagues and a lot of individuals in CBER, as well as our CDC colleagues, our CMS colleagues, VA colleagues, and many other FDA partners. And with that, I will stop. So thank you very much.
Thank you both. We have time for a few questions. Dr. Marasco.
Dr. Marasco, please make sure you're unmuted. All right, let's go to the next.
Well,
let's go to the next one. Yeah.
Dr. Pergam.
Thanks for those presentations from both of you. Dr. Anderson, I wanted to ask you specifically about how you're tracking and how the FDA, and maybe this is for you, Tom, as well, how you guys are monitoring people who are getting a second dose that is not the same as the primary dose of the vaccines they've received. And I think that's particularly important when we get into the Janssen vaccine that might potentially be a different mechanism. So do you guys have a plan or a system of how you're tracking that information and potential differential effects of that situation?
Sure. I'll ask Rich Borshi also to get on this, get online as well. So, Rich, do you want to explain for first dose, second dose?
Absolutely. So thanks for that question. We have been working with the American Medical Association and CMS since the start of 2020 to make sure we had appropriate codes in place to deal with the kinds of situations that you were discussing. So each of the vaccines that receive an EUA is going to have a specific CPT code, and not just for the vaccine, but also for the administration and the administration by dose. So currently for the Pfizer-BioNTech and the Moderna vaccine, there are specific CTP codes for first dose of Pfizer, the second dose of Pfizer, first dose of Moderna, second dose of Moderna, and the same thing is going to happen for other vaccines that are approved. So when the claims are submitted, we will know exactly which vaccine and which dose people have received. And so that will allow us to look at some of the safety and effectiveness questions that you outlined with regard to mixing different vaccines. I'll pause there and see if there's any other follow-up questions.
Dr. Gans.
Hi, thank you for this very important presentations and actually very satisfying in terms of how you're looking at these. My question for you is one way that we actually look at the vaccine in terms of the safety is actually not only to look at the baseline rate in a population of specific outcomes that you listed very nicely, but is actually to look at those outcomes also from the disease itself, so those with active infection. And I'm wondering if those analyses are going on, because if you can show differences also in rates of some of these outcomes as comparison to disease, that's an important marker of how we're sparing disease and how safe these are in relation to disease entities.
Tom, did you want to start?
Or I think I'm going to have. I was going to ask to repeat the question,
Rich,
unless you want to. Go
Rich,
ahead, Steve.
If you want. Rich, did you want to take that one as well? Because
yeah, so I can start that discussion. We have published a first paper, and we have others in the line characterizing the natural history of the COVID-19, essentially trying to look at the risk factors that put people at greater risk for serious outcomes. And so we're already related outcomes, and then that will give us a position where we can look at vaccinated versus unvaccinated and some of these serious COVID-19 outcomes. So that, in fact, a big part of the reason we did the natural history study was to make sure that
Dr. Gans, is that addressing your question, or is there another dimension to it?
Yeah, no, thank you. I just, I'm encouraged to hear that those studies are in place and will go forward, because I think that's a really important.
Oh,
go ahead, Tom.
I was just going to mention, and I know that the CDC and FDA and the VA apply certain, this is a little bit different than the question you asked, but apply certain exclusion criteria based on a history of natural disease, so the natural disease doesn't confound our safety monitoring.
And the only other thing that I was going to add is...
Okay, I think I'm going to have to break in. We're running over. And this is a very interesting discussion. And again, it's going to come up later, especially concerning how we can rapidly figure out vaccine effectiveness against some of the variants prevalent. So it's time for a break. And since we've been going so well for this period of time, let's try to reconvene past the hour. That's Eastern at 11:20, which will be 10 minutes, 10-minute break. So break time right now.
All right, Dr. Monto, I will get us. Oh, hold on.
15 minutes.
And you like how much time, Dr. Monto? For
10 minutes.